Hello, everyone. Can you hear me? Can you hear me? Hello, can you hear me? Can anybody hear me?
I can hear you loud and clear.
Okay, great. All right, thank you. All right. So it's a bit slow today for some reason. All right, so so hopefully you guys can hear me. So I see everyone's starting to come in now. All right. So let's get started. So today we're going to continue with our discussion of SNMP. Okay, so we're going to continue with that. So as you know, you had your exam on Tuesday, right? So you had your exam on Tuesday, and then so you know I'm going to work on grading those as soon as possible, and then today would be a lab session, but we're going to do half lecture, half lab. Okay, so I'm going to finish up hopefully the topic of SNMP. And then after that, we're going to do a scripting example of how we can, write a Python script to connect to an SNMP agent. So that will be part of your homework. I'm just going to give you, I'm going to open a separate Dropbox just for that. Okay, and you just have to do a simple script there. And that's going to be basically the plan for today. Are there any questions before I get started?
Yeah, the homework for tonight is not open.
Which lab is that? SNMP?
Yes.
Okay, so you're done with it?
I'm working on it still.
Okay, but everything's going well?
Yeah.
Okay, great. So, sure. I will open up that Dropbox. If you could send me an email about it, and that way, because I'm about to do the lecture right now, and hopefully that, that way I'll do it at the end of the class. All right, so if there are no more questions, let's continue. If you have, if you want to ask a question while I'm doing the talk, just speak. All right, and just ask any questions that you might have. All right, so let's see. I'm gonna switch over to the slides. Okay, so I'm switching over to the slides. Okay, and I'm going to maximize this. All right, so if you remember, we were talking about SNMP, and in particular, we're actually talking, I would say, about network monitoring. So that's really the topic that we were talking about, network monitoring. And so it's a very interesting topic, and obviously whenever about network monitoring, the classic example of this is Simple Network Management Protocol, or SNMP. So as I said, this has been around for many years, still around. There's a joke about SNMP that people love to hate it. It's this kind of a, it's there, but people complain about it. Now certainly there are other solutions out there. As I said, every company can try to implement something like this. So there are other agents that you can install on your computers, but basically they follow the something similar, a similar approach. So the great thing about SNMP is that, a lot of devices have it, and it gives us a way of looking at this entire protocol, right? And it, if anything, any company that creates their own type of network monitoring tool with agents and managers and so on, you might imagine they first will look at SNMP just to get an idea of how SNMP works, right? And then they might try to design their own applications. But at the end of the day, they're going to be very, very similar in what they're trying to accomplish. All right, so let's go ahead. So if I remember correctly, our last lecture was, we got as far, we covered this, I'm pretty sure. And then we were looking at these, the models, right, for SNMP. Oh, and I think this is where we stopped, actually. So we were looking at the information model. And as you can see here in the information model, it talks about ASN1 format, right? It talks about, so this is basically the specifics of how you, of how SNMP works, how it was defined, how it was created. So as you might imagine, it's similar to a programming language, right? In a sense. So, you guys, you've taken 110, you've taken courses where you've used either HTML or XML, right? And so basically that's what this is, right? It's some kind of a markup in a way that allows you to define this entire, architecture and the model of SNMP. So we looked at, SNMP, we mentioned last week that any network management system like this one, protocol, can be looked at from an organizational point of view, from the informational point of view, from the communicational point of view, and from the functional point of view. Okay, so right now we're going to spend a little bit of time on just the information point of view. And really the goal of this is for you to understand, okay, how is something like this built? I mean, you're not really going to build your own application of SNMP, I think. Instead, we're just going to be using it in this lab and next week's lab, okay? Remember that next week, though, you will, today I'm going to give you a script. So that basically means that, you will start now to code a little bit, right? So you're going to start to interact with this protocol, but instead of having just off-the-shelf programs, you're going to start to develop your own. And that's really the goal, so you know that, for instance, SNMP is at a lower level, right? Lower level, and then over here you have the network. But you can develop applications over here on top of all of that, right? And that's really, there's a lot of vendors, that create solutions for that. Okay, so we're gonna look then, a little bit of kind of, what goes on here, right? So the informational model, how are these MIBs? How are these OIDs? So you remember that terminology, MIB, OID, right? So how are all of these, created, organized, etc. Okay. Let's move on to the next slide. So you can see here, basically, the idea is kind of, I would describe it in programming. The analogies are data structures, right? So you define your data structures. And then once you've defined your data structures, then you go and you do something like variable equal new object, right? So you do that, you create an instance of that data structure. Okay, so that's really, the idea with this, right? So it's a managed object and you define it, and then you can create multiple instances of that. Another way that you could possibly think of it is like classes, right? So you have object-oriented programming, right? And so you define a class and then you basically create instances of that class. So that's really the idea here. So you can see, for instance, here, this is the example. We kind of create an object, right? Of, some kind of an object. And then that object has a type. all right, which means that object would have object identifiers associated with them, a class object identifier, and then specific objects within that class. And then for you to define all of that, the structure, you're going to use the syntax, basically, which in this case is just called ASN.1. And that's just, you know, it's like me saying, for instance, they're not exactly the same, but just saying HTML or XML or something like that. So it's really just a way of, you know, creating the data structure. So that ASN1, so some people don't like ASN1, other people think it's great. So, you know, there's always that debate. So you have to think of the evolution of SNMP as this thing that was an idea that was always, you know, they always had the goal of, oh, we're going to make it better in the future. It just never was perfect, but at the same time, it's universal, right? So it's around, and so it does provide something that you want, which is a capability to monitor your systems, you know, remotely. And then there's the, as far as this definition of how you do the data, right? Then there's idea of the encoding. So as you know, with everything, you're sending, you know, data through the network, etc. And so this BER, that's, you know, basically that encoding. And we're not going to go to that level, but we'll see some examples of how that works. So that, you know, that's similar to like when you have a compiled language, right? So you have the C language, but then you compile the language and you get the machine code. Okay? All right, so as far as object naming, okay, so object naming, basically you define, you know, a variable and it'll have a descriptor and an object identifier. So, you know, you can think of the variable, you know, like system name, but this, you know, will have also an object identifier. So something like this, you know, I'm just making up some numbers. So basically we'll see how that works as well, because when you do your lab next week, I'm going to give you either variable names or I'm going to give you OIDs, right? And you're going to have to query independent variables through your application that you're developing. And the idea is, okay, this allows you to both, it's a hierarchical tree, the MIB, that's basically what it is. It's a hierarchical tree of all the identifiers, all the objects associated with that device. So remember that you have a Linux host, and then you have a printer, and then you have a Cisco router, an ASA, you know, device, and so on. Each one of these will have its own MIB. And these MIBs are defined by the vendor. So this one is done by Cisco, and this one might be a Hewlett Packard, and Linux, you know, whoever, Red Hat, you know, or whomever, right? And so they're going to define, they're going to have to create these MIBs, which you can think of them as templates. So if you're working on the lab already, you've seen that to create the graphs, you have to basically select the template that you're going to be querying. So, you know, something like Linux device. So I'm gonna query a Linux device, therefore I need the MIB for that device. Does that make sense, guys? Are there any questions so far?
No.
Okay, great. So let's move on. All right, so here's the MIB, you know, so the MIB is a management information base, as I specified. It's a hierarchy of information about a device, right? You can think of it as a simple database, so no need to, you know, overcomplicate it, right? You know, kind of a text-based database. You will, in fact, you guys will implement this database next week through, you know, and you'll see it's basically just a little text file, etc. And so that will give you some insight into storing the data. But it's just a database. And then the MIB uniquely identifies specific information on all the devices, basically, such as object, type, name, and allowable operations. So you will see that defining one of these OIDs, you know, involves quite a bit. Now, within the MIB, there's something called the Structure of Management Information, or SMI. And this is yet another standard, okay, another standard. So define standard unique names for objects, right? So again, just another set of rules, like in a programming language, that tells you how you can define things, okay? How you can define things. So define standard formats for objects for use in the MIB, such as what is the length, the data type, is it integer, string, binary, etc. So all kinds of details, so that whenever, whenever you have a new product, let's say an IoT device, right? You have an IoT device and you want to create the MIB for it, then you're going to have to look at all of this to figure out, oh, this is how I create and define this variable, that variable, and so on. Okay. All right, so here's an example of an MIB. Okay, so here's an example of an MIB. So basically, this is governed by ISO standards, right? International standards. And so the idea is that you create a hierarchical tree that starts at 1. So think of 1 as the root. And then as you start, you can go in that direction, and then it turns out this direction is, I think, like organizations. And then if you go over here, then Department of Defense, because back in the day, the internet started, with DARPA and the Department of Defense. And then after that, you can go in that direction or this direction, 1, and that's going to be, I think that's the internet, right? And then after that, you decide, what do you want to do? So for instance, here you can see, you have several categories. For instance, experimental, right? So they, as they were developing SNMP, they said, well, if it's an experimental technology, we're going to group those OIDs within that. Now, companies can have their own OIDs as well. So for instance, that's why you have this private, which basically means, hey, I want to, I'm Cisco, I'm Hewlett Packard, and so I want to have my own branch in the tree, right, for my own OIDs. And then there's like a generic one here, so you can see that would be number 2, management, right? And that's kind of what we will be using, right? The generic MIB. You can see then you go into MIB2, that's just, that type of format is being used. And then after that, you can see over here, you have all of the available families of things that you can have in a computer, right? So for instance, you're going to organize your OIDs by system. You're going to organize them by interface, let's say by protocol, ICMP, UDP, and so on, right? TCP, obviously, important one. And so you can basically now start to structure the variables. And this was because really all devices, right? All devices that are connected to the internet have some kind of a network interface, right? So there is that. So there are some common themes. If you were talking about the Internet of Things, you would probably then need a new branch here for sensors, right? Sensors, which not all devices have sensors, but OIT devices do have. And you can see how this is pretty flexible organization. But this is basically how you create for a given device the MIB, right? So you have to think in terms of organizing every variable within these categories, and then you can trace something. So if I want an interface, right? I want an interface over here, then the OID is going to be 1361, 2, 1, and then 2. And then within that category, there might be individual interfaces like 1, 2, 3, and so on, right? So that's basically the idea. Are there any questions about this, guys? All right, it seems like no questions, okay? Stop me if you have any questions. All right, so, but this is an important thing, okay? This is an important thing because when I give you, let's say, the next homework assignment next week, I will say query, the following 5 variables, for instance, right? So I'll probably say that. And so you need to figure out what their OID is going to be, or maybe I'll give you the OIDs and then you have to find what it actually means. Okay, so understanding how things are organized in the MIB is very important. Okay, which is a hierarchical tree that has been just the fundamental aspect here. Okay. So here you can see if you're talking about a private MIB, then it's going to be 1361. It didn't go into the generic management one that we looked at just now, right? Instead, it goes into a new one. So you have private, and then you have enterprises. You have your Cisco's and your Hewlett Packard and so on. Okay, you can add more. Let's say that Tesla, right? Tesla nowadays has a lot of cars that are connected to the internet. Well, it could be that Tesla, or they have their power batteries that they have at homes and things like that. So they could create their own MIB. There's no reason why they can't do that. And that's what the protocol, allows to do. So that's why it's universal and extendable. Okay. So basically the 3 parts of SNMP, there's a lot that goes into a protocol like this, a network, and that's why it's difficult to develop, other network management protocols or other network management applications, because a lot goes into this, right? And the problem is one company, Microsoft, might develop it in one way, but then Linux develops it in another way, then Apple develops it in another way, then Huawei, and so on. So every company starts, looking at how they want to monitor their data, and at the end of the day, it only works for that specific service. So that's why SNMP has lasted, because at the end of the day, people, they might end up buying a Microsoft product, NetApp or something like that, but there's that one device, and that one device has to be monitored through SNMP. So you never know, you have an older device or newer device, and so you have that discrepancy, right? And so that's why, this protocol is central to network monitoring. All right. So it's based on, so network management, such as SNMP, is based on 3 parts, right? So they have the protocol, the SNMP protocol. We have the MIBs, of course, and then you have the structure of management information. So the SNMP protocol defines basically what the way that I would think of it is the packets, right? So the packets defines format of messages exchanged. So that's really the packets by any management systems and agents. And at the end of the day, any application will do that, right? And these are, we already talked about these. These are governed by get next, set, and trap operations. Very simple, right? So not very complex. Then you have the structure of management information, and that's just, or so-called SMI, and its simple definition is just rules specifying the format used to define objects managed on the network that the SNMP protocol can access. And so, I like to think of it as just the syntax, because that's what rules are, the syntax of the data structure. Oops. Of the data. Nope. Structures, okay? And then finally, the MIBs, they're databases. So they're databases, right? It's a map of the hierarchical order. So we just saw that, the hierarchical tree of all the managed objects, which are the variables, and how they can be accessed, right? And so, those are the things that allow you to define. And then from, then below SMI, there's like BER and ASN1 and so on, okay? But that's, that's the protocol itself. All right, so you know, here's an analogy that's sometimes good, you know, if you want to remember this for your exam or something like that, you know, comparing computer programming and network management. So at the end of the day, you want to manage your devices in the network. You got all kinds of vendors, right? So you need to have some kind of a protocol like SNMP, and that's just, well, that's the coding, right? So that means that you're going, as we're going to do today at the end of class, we're going to write a script. Hopefully you guys had an opportunity to install the PySNMP library last week, right? And so, and there's, you know, a lot of solutions out there. And so SNMP allows you to do this, right? To do the coding. And then that's going to use the MIBs, which you can think of them as object declarations and definitions, right? The so-called data structures or databases. And then the SMI at the lower level is going to be the language syntax. Like, you know, it's not C++, but, you know, the language that you're using there. Is this clear, guys? Any questions? All right, seems like no questions there. Okay, so let's continue then. All right, so here's a little graph animation, and it just shows basically the flow of SNMP, how it works. So at the heart of this, notice there's a manager and an agent, right? So the manager wants to query the agent. You know, the manager can be anything, you guys, you know, your laptop or whatever. And then the agent could be a printer, router, switch, UPS device, you know, power, any kind of thing, right? So air conditioning, HVAC, whatever. So you have basically the manager, the administrator, the system administrator, right? So sitting, he or she is sitting in their office, and they want to query, you know, they want to know what is the number of UDP user datagrams received by that device. So I want to query that variable. It is of interest to me. So I'm not just like guessing, right? So that's the great thing about this. You're not guessing, you're getting the real data, right? And so that helps you to make your decisions to monitor your network. So then you make that question, right? And so what happens is, that's the question that you want for your laptop. Then your laptop or your software, basically, your SNMP software, has to really look at these things, right? So it has to look at these things. So what do you want? Well, I want UDP user datagrams received. Okay, so I need to check, that was defined by SMI. That variable has integer values. Okay, so integer values are defined using 3 attributes. Okay, so basically that's the first thing you know. Okay, it's integers. Let's summarize it. And then after that, in the MIB, you want to know the object has an integer value, and it is called UDP in datagram. So now you actually have, before you only had the question, now you actually know the name of the variable that holds, the name of the variable that holds that data. And it just so happens that in the hierarchical tree, it is in that group and it is that value, right? So you can have more than 1 or 2. All right, and so that's defined in the MIB, all right? So you already know that, let's say this is a Hewlett-Packard device. And so here you have that Hewlett-Packard, either call it a template or the MIB definition. So you have that already in your device, in your software. Okay, great. Then once you've done that, you have the OID, you have the variable. Now you're going to use SNMP, and you're going to use SNMP to basically encapsulate. So you're going to encapsulate the request in a GET request message. So now you're going to use the network protocol, the packets, and that's going to, the software that you wrote or that you have, CACD or whatever, is going to create that that request and send out that packet. You can see then the packet is constructed. it leaves the machine towards the agent. So it's going to be an SNMP packet, and it's basically a GET request. Then the agent receives the message. It does the authentication through the community string, checks the network ID. There's a match. Then, then it's going to reply, right? SNMP packet response. So now you receive the response. You're going to interpret it again with your SNMP information, and then now you will have an answer. You can see the answer goes back over here. And that's basically the mechanism. Pretty straightforward, not very complicated. And that's the protocol. Okay. All right. So now you can also think of SNMP as having several languages, right? So having several languages. You can see those over here. This part, in our lab, we're not really going to go that deep. Okay, we're not going to go that deep. So remember, this would be more, at the MIB. So you have, I would say there's MIBs, SNMP, the network, and then there's your apps that you're building, right? Your apps. So this is more, going in that direction. So, we're not defining MIBs in our labs, for instance. We're just going to use the ones that already exist. And so really our focus is here, but these are more about what, how to define things at those layers, okay? At those layers of the protocol. So you have a few languages to be aware of. SMI, of course. There's the ASN1, which stands for Abstract Syntax Notation 1, ASN1. And then you have the basic encoding rules, the BEAR. Okay, so the structure of management information basically specifies the format used for defining managed objects that are accessed via the SNMP protocol. Right, so I would say that's, that's like a higher level version of the language. Then you have the ASN1, which is used to define the format of SNMP messages and managed objects using a data description format. Right, so we'll see some examples of how that works, okay, in a second. And then at a very low level, you have the BEAR, which is the encoding scheme that you're going to use, right? So converting things from ASN1 to, like binary, all right? So used to encode the SNMP messages into a format suitable for transmission across the network, right? So obviously you want this to be fast, right? And so SNMP, it's not necessarily very efficient for speed. And that's why we'll see later on that encryption is something that is not always pursued. Remember, this is an internal network kind of a protocol. So you're assuming that you're managing not over the internet, but behind a firewall. But the encoding is important because it will have a hit on performance. Okay, and so we'll see later on that adding encryption and things like that makes it even more of a burden. But anyway, these are the languages. These are the languages of SNMP, right? So how it is defined behind the scenes. Okay, so so management information bases or MIBs. So let me do this. So MIB is one thing on top of SNMP. Okay, so they're kind of like two separate things. You can have the SNMP change the SNMP protocol, and you don't have to change the MIBs. Or the other way around, you could change an MIB, you can create new MIBs, and you don't have to change anything in SNMP. So that was made that way so that you could add, because obviously there's hardware is changing all the time, etc. Right? So SNMP does not define which information or which variables a managed system should offer, right? So it doesn't. So you have flexibility. Obviously, you have some in common, like network adapters and so on. And yet SNMP uses an extensible design, which relies on these MIBs. So available information is defined by management information basis. Okay, so hopefully that's clear by now. Okay. Now, the ASN one, let's take a look at that. As I said, we're not really going to use it that much, but let's take a look at that. So the abstract is the syntax, basically, as you can see in the name there. It's the abstract syntax notation one, which is, it's like, I would say, it's like an XML. I think I've read that some people have thought about, what if we did a network management protocol, but instead of using ASN1, we use XML? So it's just, as you can see, it's just another way of, or another one would be JSON, right? So, I'm sure you guys have come across JSON. And so all these things is they're basically, like JSON is really like a dictionary type of a structure. XML, it's a tree of nodes with nodes inside of them. And so they're just ways of trying to encode information. And that's what ASN1 is. That's how I would describe it in simple terms. Has some advantages. It is pretty standard, obviously. That was the whole point, that the second you say we're using ASN1, everyone across the world, oh, okay, ASN1, that makes sense. They know what you're talking about. It is a flexible notation. It allows you to describe data structures for representing, encoding, transmitting, decoding data. So, it provides that flexibility. It's a syntax, so it has a set of formal rules that describes the structure of objects. Okay, the structure of objects. And it is independent of machine-specific encoding schemes, right? So that's one of the objectives, that it can be used across, all kinds of vendors, Apple, etc. Microsoft and so on. And it's precise, formal notation that can minimize ambiguities, and you want that, right? And even though you have this, that doesn't mean that, there's a difference between having a great language or structure and then the coders that implement things. So the coders always, when you guys take software assurance, you'll see that, the principle there is that people make mistakes when they code, and so, there's issues even with SNMP and how it is implemented. Okay. So SNMP, SMI, so you can see here, so, in SMI, basically, is the variables recognized by the device in the MIB. And it's, it's basically, you can think of it as a text file giving variables and data structures using ASN1. And so that's it, a text file. So everything in Linux, in a lot of computers, basically text files, and then they're written in this structure for, and it uses this idea. So I think this should be clear at this point. So I don't want to get, keep repeating myself. So I'm going to move on to just some examples of how this can be done. Okay. So I've set this. Okay. And here's an example of, in an MIB. So it's an example portion of an MIB. And it's basically for the interfaces, right? So you can see that you have one variable. So this is the definition of just one variable, right? And it's basically a computer, right? And it has a network card or two, right? And so you're going to use this this syntax, basically. You're going to use this syntax to define it. So as you can see here, implementation of the interfaces group is mandatory for all systems, right? Because they're all network connected. So you can see here you have interface number. You say it's an object type, and then you specify that it's an integer, read only, right? You can define access types here. Status mandatory, it should be there, and then it provides a little description. The number of excuse me, the number of network interfaces present on the system. And then this one identifies that it is interface 1 because you could have interface 1 and interface 2. Okay? And so this is just an example of how you define the variables in your MIB. Does this make sense, guys?
Yeah.
Yes.
All right, thank you. So no questions, it seems. All right, and so that's, that's it. So if you see over there in the previous example, we saw the definition. So it was interfaces 1, right? Interfaces 1. And that is part of the interfaces group. Therefore, if you remember, we had, a tree like that, and it goes like that, and so on, right? So we had all this tree that defines the MIB. So you can see variable names are aliases for digit strings within an MIB. We saw that the interface was 1, right? We saw that the interface was 1. So therefore, if the interface 1 is part of the group 1, 3, 6, 1, 2, 1, 2, then that interface is now 1, 3, 6, 1, 2, 1, 2. Oops. 2, 1, right? So that, that gets added. That now this defines the OID of that interface, okay? And that's how that works. That's how the data is organized. And a lot of things, Active Directory, et cetera, also follows something like this for all its variables. So it's a very common thing in computing, actually. Okay. All right, and here's another example. So you can see here, the 1361, that's pretty standard. And then everything just follows, the sequence. So down here, 1361 is 2, 1. So 136, 2, 1. Okay. So I think that should be obvious. All right, and then I'm going to go through these kind of fast, but these are just examples of other uses of ASN1. So as you can see here, ASN1 is nothing more than a language definition. So it's similar to, let's say, C, C++, or other programming languages. You can see here, you have some examples of variables and how you can define them. You can even create like arrays and so on, okay? Or data structures. And here's another example of system context. So for instance, I think I said in the lab document that one of the things you have to do is you have to have a variable for system context, right? You have to change that, I think I said. And so you'll change that in the configuration file, but then just be aware that configuration file does have a definition in the MIB, right? Chris, and so on. All right, so those are examples of how to use the syntax to define the OIDs in your MIBs. All right, so I think we're done with that part of defining the MIBs. Now we can just look at the other definitions of the protocol. So, this is basically the packets for SNMP. And you can see it, as any other packet you might imagine. It carries certain information. So the message length, it carries the message length, version, the community string, a header, and the body, right? And so that's the information that every packet is carrying as it's making a GET request or it's getting information back. Okay. You can see here, here's the examples of the different communication that you have between a manager and a server. Right? Oh, sorry, manager and an agent. Okay, between the manager and the agent. So usually the manager will do a GET request, GET next request, GET bulk request, or a SET request, which remember we're not really using in our lab, because we really just want to monitor. We don't want to manage. Okay. So Then we also talked about, obviously, when you get a request, there's going to be a response associated with that. But we also talked about the trap, right? So we talked about the trap last week. So that should be very familiar to you. And that's just a situation where the agent detects that there's a problem. Maybe there's two power supplies and one gets disconnected. So then it sends a trap to the manager. And then the trap can do many things, right, to find more information about that issue. Now, there's an additional thing that managers can do, and that is they can send reports or information requests to other managers. So managers might have a manager covering one sector of the company and then another manager covering another sector. And then every now and then it's like they're going to sync, right, and exchange data to stay informed, right, to monitor everything. All right, I'm going to go through the bare encoding rules. I'm not going to spend too much time on this because this is, getting at a too low level, right? Where, you're rarely ever going to have to worry about this. But basically what I can say is the relationship between ASN1 and bare, right, parallels, the relationship between your source code and machine code, right? So if you have a C language or some programming language and then you compile it, right, and then now you have the machine code. Well, that's kind of the same as you have your ASN1 and then you have your bare, right? So they're kind of basically similar there. Right, so we can skip this part. This is just an example of how the data, the 1361 gets encoded into binary. So it's an example of that. Okay, so now we're pretty much done with a lot of those definitions of the languages that are used for the communication, right? Like ASN1, SMI, bare, right? And now we can focus a little bit more just on the communication, right? And this is more specific to SNMP. So if you remember, this is not really about MIBs now. Remember, you have the app over here, and then you have SNMP itself, right? The network. So we're really going to look more a little bit more at this part, right? So the processing of the packets, how the communications work, etc. So you can think of it as the communication model or the point of view that we're going to use. So here, the SNMP communication, happens between a manager and an agent, right? Manager and an agent. So obviously, here's the physical network, right? And then, the IP layer there, doing this over UDP. Then you have SNMP, and then here, basically, at a very higher level, you have, your management data, and then you have the app, right? So the application of the agent and the manager and the flow, right? So the manager sends get requests, set requests, and then receives traps, for instance, right? And that's the relationship of how the packets flow in this protocol. So that's what the SNMP communication refers to. Now, SNMP communities, right? So this really is the community string. The community string, right? So if you've read the lab, what's the community string that's being used by default in the lab? Anyone tell me? What is it? Those of you that have completed the lab? Josh? Zach?
I couldn't tell you.
It's the public, right?
Public, yes, public, exactly.
Oh, yikes.
Yeah, so that's in your lab, right? So that kind of tells you where you guys are in your lab. So public is the community string that you're seeing there in your lab, okay? And it's basically a password. We'll talk about the versions, but version 1 was basically clear text, clear password, you know that when you're sending a password in clear text, it can be sniffed in the network. So it's not great, but at the same time, it's not going through the internet. Remember that. So anyway, that's what this refers to. So I don't know where this name SNMP Communities came from. That, it seems like a strange name instead of just calling it password, but basically define communities, okay? Specifying access to specific variable sets, right? And you'd have read, write, read only, none. So this is something that you implemented in the access control file, right? So you worked on this, you're doing this in your lab. You're setting the parameters for the access control of agents. Usually you go to the agent and you modify there. You modify that there, the access control. And basically what that involves is the permissions, that involves the network IDs that are allowed through, and also the password, right? So it's basically a password that is provided in each packet. You saw that, that was carried in one of the packets that we looked at, somewhere on here, community string, right? And so that's, the de facto password, basically. And, believe it or not, it's unencrypted in versions of SNMP that are still widely used, okay? And as I said, there's basically 3 versions. We'll see that, version 1, version, I think it's 2C, and then there's version 3. Of these, the only one that's encrypted is this one. The problem is there's, it's not very efficient, right? And so internally in the network, people revert back to version 2C. And this is actually the one we're using in the lab, okay? In this lab assignment. But anyway, this at least has the password. The password, okay? At the end of the day, you could argue that, so there's one thing I need to point out. So SNMP is not sending emails, right? So it's not like you wrote an email and it's gonna be sent through SNMP. That's not gonna happen. Or you're not setting data, so that's also that issue. You're not sending your bank information or credit card payments, or you're streaming your movies or anything like that through the SNMP protocol. Remember that SNMP is just carrying, basically it's like metadata is the way that I would describe it. It's carrying information about the computer, but not the information that the computer produces, or not the content, right? Because that's really what computers are. They're mediums for creating and exchanging content. But this is really, SNMP is the metadata. So it's like how many packets were sent. So can a cyber criminal infer something from that data? Sure. But it's not like they're stealing your email through this. So I should say that because, as we're going to see that the protocol is a little bit insecure, but at the same time, I should stress that it's not exactly that it's carrying all data. It's only carrying metadata about the system itself, like the printer, how many. It's not like it's going to print the financial statements or the stock market information about the company. It's only going to say how many bytes were produced, and so on. All right, so that's important. So we talked about SNMP communities, which is the security, one of the security topics. All right, so now ports and UDP. Okay, so that's, SNMP uses UDP, User Datagram Protocol, as the transport mechanism, right, for SNMP messages. So it doesn't require anything that's like very reliable, or established connections. It's really just, send the data, query it again, right? So you can see here the SNMP message, and it's encapsulated in a UDP packet, and then you have your other headers. SNMP uses 2 well-known ports. So I think that's one of the reasons why in your lab, I asked you to use like Nmap or one of those. I believe I did that. And that's just so that you can view these ports, right? That these are the ports that are available. So you have port 161 and port 162, SNMP. You can also do netstat, right? So netstat dash NA, pipe, grep, UDP, right? And that should give you about the same information. All right, so now we can move on. So SNMP message protocol. So it uses UDP ports 161 for requests and responses, and then 162 for notifications. And we already know the message types are get request, get response, set, trap, and so on. So we already looked at those previously. Okay. I think this is a graph. Very slow to load. All right, so here's an example of just how the ports are used. So you can see here, you know, you have the server and the client, right? And so active, you can see that. And then for instance, you know, it's 162 we said is for notifications, right? So it's just waiting there. And then if a notification is needed by the server, it'll open up a port and then it'll send it to 162 on the other end. Okay. All right, so that was, yeah, that was, so we've basically talked about these three, and now we're just gonna kind of, if you remember, we started with this, right? So when I started the lecture, I talked about, you know, not in SNMP, but in network management itself, what are the goals, right? What are the goals or the functions, sorry, goals or the functions or functions of such a service. So it should be very clear to you that you want to have, you know, in an organization that's really large with a lot of servers and devices, it would be nice to have an automated way, a NOC center, basically, a network operations center, a way of querying all devices for various goals or functions, okay? And so that's really, you know, we're gonna kind of go back to this. So the functional model, you know, basically it addresses, you know, configurations, faults, performance, not so much security and accounting, right? So these are the things that you want to monitor, right? So, you know, what are the configurations? Is there a fault in the network? How is the performance going? So that's one of the things that you guys are doing in your lab by having, you know, graphs, right? So you guys have graphs in there and you can measure information, etc. You can keep track of the devices, do some kind of an accounting, etc. Right? So that's basically what, you know, just a reminder of what the network monitoring helps you to do. Are there any questions so far, guys? Okay. So in this part, we're just going to look a little bit at the history. All right. So, you know, I've mentioned this a few times already in the slides, but, you know, we're going to go over the various versions of this. So obviously, SNMP started with version 1, it's the initial implementation. And as I said, you know, SNMP, as I said, it's a great goal. Sorry, network monitoring is a great goal, but SNMP has been criticized over the years. People love to hate it, right? So it was criticized certainly for two things in particular. Version 1 for poor security and also for the fact that it was not very efficient. So it was like, it sent very small amounts of information, it was slow, you know, that kind of thing. And so, as you might imagine, in other versions, this was improved. But in particular, it was criticized for poor security. You know, the authentication was done by a community string. You guys that have taken 350, you know, we've explored this, and authentication is achieved, you know, through cryptography, etc. So there are more advanced mechanisms to achieve authentication, not just passwords. All right, so and you know, it's transmitted in clear text. So you know, there was that issue. You know, and this is kind of what SNMP was and still sort of is, that it was built as an idea. It was approved based on a belief that it was an interim protocol needed for taking steps toward a large-scale deployment later on. So the idea, it was interim, right? So it was interim, and that just means that, so it was interim that they planned to make it better. It's just that that never no one found a way. I mean, it's a complex thing to do, right? So no one has found a way of doing that more efficiently, if you will. But it is, you know, it has become the de facto network management protocol, right? So, you know, although, as I said, there are solutions out there, even those solutions are kind of built on the same ideas of SNMP. Version 2, of which you guys are using 2C, you guys, if you notice, whenever you do your queries, you specify that. So it's a revised version of 1, obviously. Improvements in the areas of performance, right? So that, you know, they made it more, tried to make it better. Certainly version 2 is better than 1. Has a little bit more of the security component in there. You know, introduce get bulk. To basically to retrieve large amounts of data. All right, so you know, basically ways of being more efficient in the coding, how to move large amounts of data. And you know, they implemented some kind of security mechanisms which were not used because they were considered to be overly complex. You know, as you know, we learned this in one of the labs in 350, right? That cryptography affects performance, for instance. There's no question about it. And so when you're sending all this data, you know, that just hinders even more, puts a burden on the network. So some people, because this is inside the network, still accept, you know, this version, basically. Okay, so overly complex. All right, so now let's look at, so you know, basically there's a little bit more information here. So, you know, it has this feature of being bilingual so that they're actually not exactly compatible, version 1 and version 2. So they have to be bilingual basically so that they, you know, if you're using version 1, you can talk to things that are using version 2 and so on. Okay. And then there's version 3 of SNMP here. And that's basically now, it provides important security features, okay? As you remember, we learn in 350, or you will learn in 350 about, you know, the principles of information assurance, like integrity, authentication, confidentiality. Right, and so on, right? So this is what you're trying to achieve now, and it just makes sense, you know, that this is the standard approach, right? So message integrity, ensure that the packet has not been tampered with in transit, authentication, verify the messages from a valid source, so there's no, you know, non-repudiation, right? And then, you know, prevent snooping by an unauthorized source, which basically means confidentiality, okay? Confidentiality. As I said, I've already said this, but my view on it is that, remember, you're not sending emails or your, you know, data. It's just metadata. So there is that element. Obviously, if you were sending, you know, more critical data, you know, that would be very problematic. Also, and this goes back to the recommendation of not using set. All right, so definitely using the set method in something that is unencrypted is terrible, right? So that you would never want to do. When you guys take 454, we're going to look at something called session hijacking. And in session hijacking, it's basically about creating a packet, changing the set parameters to whatever you want, and then hijacking a computer. So giving it an instruction that it wasn't supposed to get. So obviously here you do have a risk of something like session hijacking because the packets are not encrypted. So somebody could monitor the packets in the network and then spoof new packets using version 2 unencrypted and set instructions on the machine and cause serious damage. So that's why, definitely the recommendation only get not set. Right? If you have confidentiality and encryption, then set becomes more of an option, right? Because then session hijacking is basically impossible when something is, or I shouldn't say impossible, but it's less likely when something is encrypted. Does that make sense, guys? Are there any questions? You guys hear me?
Yeah, I don't have any questions.
Yes, sir. No, I have no questions.
All right, great. Let's see what, yeah. So I'm almost done with these slides. And then after I finish the slides, we're going to write that script. So let's see. So hopefully it makes sense, right? So, you talked about the history of it and then the different versions. So SNMP implementation. So to wrap up, SNMP implementations vary across platform vendors, right? Sometimes an added feature, you create the printer and then you're like, oh yeah, we forgot the SNMP part. So, that there can be issues with that sometimes with the implementation. It's not an element of the core design. And using SNMP to query certain data sets may result in high CPU utilization. So there are negative effects on operations. So it does have some negative impacts, obviously, but at the same time, you do want to monitor and get information about your network. And so you got to find a trade-off, basically. Security implications, 1 and 2C are subject to packet sniffing, right? So I talked about that. We'll learn a lot more about that in 454. The clear text community string for the network traffic, no encryption. They're subject to brute force, right? A lot of people just use the password public and leave it there because it's confusing. And so if you have that, you don't even need the encryption doesn't do anything, right? So so it's subject to brute force and dictionary attacks for guessing the community strings, and it's vulnerable to IP spoofing attacks, which is what I was saying, like session hijacking. Right? So that's definitely very, very problematic, and that's why you want to have the set element disabled on this approach. Okay. And then so let's see. So so the recommendation is, of course, if you're not using SNMP, disable it. Block all SNMP traffic at the site perimeter, right? So that it's only on the internal network. Use secure shell whenever you can, or encryption. And then basically, if you have software that uses SNMP, do patching, etc. Okay, so those are just some of the recommendations of this. And then, that kind of wraps up the discussion today. I think I showed these slides last week. And basically, if you're doing your lab, you've already seen things like this. So this is not CACD. This is just another example. There are many vendors, as I said, but it's the very same principles. You can see here, they have some kind of a device, a catalyst switch, right? And then the device, you have the community string there. You specify the version that you're using, and then these are all the OIDs. You can see like system uptime, system contact, location, and interfaces, and so on, right? And so these are the variables that are available in that device. And then when you query it, you know, let's say you query a router, now you have the graph, right? So in this case, this is over time is the number of interface in octets, right? So this gives you a nice little graph of the utilization of the system. All right, and this is what you guys will be exploring in your lab. So remember, as I said, you know, at the end of the day, SNMP is a network monitoring protocol. It is the de facto, in fact, but there are a lot of other solutions out there implemented by other vendors. So you can always install, you know, some kind of a monitoring software on your computers called an agent. And that just, you know, the idea is it collects information and sends it back. So it's pretty much the same, regardless of what the vendor is, same ideas. You know, it's not always the most secure unless you have really good encryption. But when you have encryption, you have performance issues. So there's that trade-off. So recommendations are to use it as needed, definitely in the internal network mainly. Because of session hijacking, you don't want to set parameters and so on. All right, so that's kind of the idea with this protocol. Obviously, if you wanted to implement this in the network, you have to use encryption, okay? And you have to make sure that the data, you know, basically has, you know, the transmission of the data follows the principles of confidentiality, integrity, and authentication. All right, and then this is another example of some tools out there. As you can see, they provide a lot of data, right? A lot of data there, you know, for monitoring, you know, devices. Notice here, they start to provide, you know, ways of visualizing the data, monitoring it, and doing maybe things like writing reports and so on. Okay, and that, you know, pretty much, you know, what I've said. SNMP is a protocol to define a framework of network management tasks. By itself, it's just a definition, but it must be made real by products. Okay, and some of these products people sell to you. All right, that concludes. Let me show this. So now that I've finished with these slides, let me go ahead and okay, so now I'm going to share a virtual machine. Okay, here we go. So let's screen. All right. So can you guys see my VM?
Yes,
Yes?
sir.
Okay, great. All right. So we talked that. So that concludes the SNMP lecture. All right. So hopefully next week we're going to move on to another set of topics, but still it'll tie in a little bit to SNMP, and then we'll wrap up that topic. So what I want to do now is I want to give you a script that, well, I'll give you the starter script, and then your assignment will be basically to complete the script, right? So you'll have to use the script with one of your SNMP agents, right? So you're going to use the query as if you were the manager in Python, you know, and then you're going to query the SNMP agent, and that'll just show you that you can actually write code, you know, and interact with an SNMP protocol. Okay. Now in this script, you're only going to get text data, but next week we will see that text data can also be, you know, but just by writing more code, you can generate graphs and things like that. So that's really the idea, and we're going to talk about Apache anyway, and so that way we will, you know, we'll tie both services. Now, remember that Apache, the next topic, is a very important topic for Linux. It's really how Linux became a very useful tool. All right, so let's go ahead. So if you want to follow along, go ahead and start your seed VMs. So if you notice, I'm just using seed. And the script is actually pretty short. I'm just going to give you one, and then I'm going to create a Dropbox for it. Okay, so this is just a warm-up example. And the idea is that you should, just interact with SNMP through scripting. All right, so let's go ahead and start a terminal. Okay. So I'm going to navigate to the desktop. Okay, and then I'm going to navigate to our folder. Okay. All right, so all right, so we can create a script here. I'm actually I'm going to create a directory and call it SNMP. Right. All right, now in here, I'm going to create a simple script. Simple SNMP .py. Okay, so we said, in the previous lab handout, we discussed that you wanted to use the PySNMP library, so you can do from PySNMP dot entity dot RFC, the reference 3413. You're going to bring a module called one-liner, and one-liner basically, as the name implies, it allows you to write a lot of code in just one line. Okay, it makes it efficient. And then from one-liner, you're going to import something called CMD gen. Okay, so command generator. Okay, so now command generator, we're going to create a variable, and I'm going to call it CMD. I'm going to use uppercase G here for the variable, and I'm going to add a 1 just so that it's obvious that that's a variable, CMD gen 1, and then now call the module CMD gen and dot, and you call the function called command generator. Notice the uppercase G here, right? Everyone with me so far? Yeah?
Yeah.
Okay. All right. So we create the command, right? And then it's pretty easy. It's because we're using this one-liner, we're just going to specify a command. So we're going to use CMD gen 1, right? And we're going to call a function called get command, right? And then we just need to specify the parameters for it. Okay, this function returns actually 4 variables. So this will return, some error information. So let's call it error indication, comma, error status, status, comma, error index, you know, so a lot of error information. And then the data will be stored in this variable. I'm just gonna call it var binds. You can call it whatever you want. It's just a variable. And it's actually, it's like a structure of tuples, basically, a structure of tuples. You'll see that. So it'll be an object that you can iterate through, and it'll allow you to display the data. All right, so then, you know, once you've done that, so I'm not gonna make this script very complex. Obviously, I could ask you to write like for loops and everything of querying a lot of variables. I really just want you to, you know, make sure that you run this one and it's ready to go for next week, kind of to make sure that your library is installed and everything, because next week you do have more code, given that you'll be building an app on top of SNMP. It'll be a type of a web app, a very simple one, but you know, a website type of a solution using Apache. All right, so anyway, so now that we have this, we can still specify in here that we need some parameters, right? So we can use CMD, the module, CMD gen, right? CMD gen, and then we specify some parameters. So we can specify community, community data, and that is basically the community string. So what's the value here? What would be the value for your machines?
Public.
Public, perfect. Who was that?
Yash.
Josh, yeah, very good, Josh. So public, right? That's the community string, which is the password, comma, and then we do CMD gen dot, and then you specify you're using UDP. So that's the transport target here. Oops, sorry. UDP transport, right? And then target here, and then here you're going to basically specify the socket, right? So you're going to use a tuple to specify the socket over here, and that's going to be dependent on your network. So for instance, I'm just going to use 192.168.1.11 as an example, right? So it's going to be the IP address of your agent, basically. And then you're going to specify to connect to port 161, because as you're doing your lab, you've confirmed that when you start an agent on UDP, port 161 should be open. All right, and then after that, you're going to specify which variable you want. All right, so it's going to be CMD. Sorry, I wrote get here. This should be gen. Sorry. All right, and then down here, CMD gen, again, the module. And now you specify the MIB that you want. So MIB variable. Oops. MIB variable, and it's going to be in this case, I want you to query, you're going to use the format SNMP version 2 MIB, right? So we saw that version 2 MIB. So it's just a format that you're using. And then I want you to query a variable. So in particular, you can try other variables if you'd like. If you find their names, maybe you do an SNMP walk and you get the names. But I'm just going to specify one example here. For instance, query system description. Right. So most systems should have add an R at the end. Most systems should have a system description parameter. Okay. right? And then, so then after that, comma, then you're going to try, there's a few additional parameters here. So, you know, it can look up the variables based on their names or their values. Okay, so you can specify lookup names. Lookup names equal true, comma, lookup values equal true. Okay. And that's the last one, right? So you don't have to add any more commas, remove this space here basically. And then once you've done that, this one-liner defines all the communication information that you need, right? So all the communication, and then you send this is going to produce get request packets, right? Get request packets, and then after that, they will be returned to these variables, right? So now what you need to do is you need to print out the data. So for instance, I'll do an example, check for errors and print the results. So I can do if, let's say error indication. So like if it's true, if error indication, which means there's a value in there, then 1, 2, 3, 4. So you're going to print. Now, if you're using Python 3, this will work. If you're just using Python 7, this would work, right? Either one. So just try it out. So print error indication, right? And so on. You can do this for all the errors. I'm not going to do it. And then finally, though, if there are no errors, you want to print the actual result. So there you have to do 1, 2, 3, 4. And then you're going to do 4. And now you're going to iterate through the tuples in var binds, right? So in var binds, you can do for name, comma, value in var binds. Remember, var binds is this one over here. So in var binds, var binds, right? Oops. In var binds, 1, 2, 3, 4. And now you're just going to print the results. So the results of this would be print, right? And then you're going to do single quotes. You can use format string. So %s equal %s, right? And then you specify what the parameters would be, which in this case are name, comma, val, right? And strings sometimes have a function called pretty print, so you can try that, see if that works, or just format it however you want. But you can do like pretty print over here, val, pretty print, and so on. All right, so that's basically the script, as you can see. Let me save it so I don't lose it. It's Control Y. All right, and you can see there's the script. Okay.
Are you supposed to have that many parentheses at the end of the last line?
At the end of print, let's see. I have one here that I close here. Then I have this one for the tuple, which is this one.
Oh, okay, I see it.
Then I have these, yeah. So no, it's a good question. Yeah, but it seems like that's the right number. Sense?
Yes.
All right, that's it. Okay, guys. So really easy scripting example here. I just want you to make sure you finish this script, run it, try it out. And you should get, obviously, if you have a Linux machine, it'll print out something like Linux machine. Maybe it'll say seed Ubuntu 1604, something like that. Okay? So that's really all that I have for you today. I want you to work on this script. Make sure it runs for next week, given that next week we will be talking about Apache and using Apache in conjunction with SNMP. All right, and so although it's a lot of coding that you'll have next week, I will give you the code. So it'll be actually just running it. I mean, it won't be that. The Apache part will be more difficult, honestly, than the scripting part. Okay, so that's it. I saved it. So are there any questions before before we sign off today?
Is Pi SNMP one of those things that you have to download and install with pip?
It was in your lab handout. I think what I said was, because there's a lot of ways of installing something in Python, right? Like Anaconda, pip, but there's something actually in this lab. I gave you an example of another way, which is I think you have to install first setup tools, if I remember correctly. And then once you do that, that gives you a script called easy install. And so sometimes you can use easy install to install things easily.
Okay.
Yeah, so it's just another way of doing things. But I think that should work. Okay?
So does this script needs to be
Can you speak up a little bit, Yash? I can barely hear you.
Yeah. So for this script, does this needs to be attached to the SNMP lab?
That's a good question. I usually, it makes it difficult for me to grade things that way. So what I'm going to do is I'm actually going to create another Dropbox just for this, okay?
That's due tonight, right?
This one?
Yes.
No, this one is due next week.
Okay. And the
This one.
SNMP is due tonight.
The SNMP is due tonight, yes. Are you guys on track to submit it tonight?
I am.
Yeah.
Is anyone not on track to submitting it tonight?
I'm not.
I'm not.
You're not.
No.
How about the weekend?
Yeah, I could probably do that.
Okay, so I'll leave it open until Sunday, okay?
Okay.
All right, but because next week we're doing another one, and we kind of need to wrap up. Before I sign off, I want to remind you. I've seen some of you already finish your Hadoop, at least single node, and sent me some results. Looks good. Make sure you do at least a cluster of 2 if possible. And then I remind you also that the project B, right? You're gonna pick a topic in system administration and present it. So it just has to be something that you're going to implement. So please send me emails about your ideas, okay? You can do that project in groups of 3. Just pick a topic. You can pick like maybe another SNMP tool that you find online or something like that. Is that clear for everyone, guys?
Yes, sir.
Okay, so please remember, it's not a lot. It's only worth like, if you think about it, your projects are 10% of your grade. 5 is the Hadoop. So the topic is only 5 points, but still please, it doesn't have to be huge, but just something interesting. So we don't, system administration is such a wide topic or such a breadth of topics that I can't cover everything. So find something else related and then, do the presentation. However, the requirement is something you implement, right? Either you write a script, or you find a tool and you configure it in Linux, one of the 2, okay? So please send me one person in your group an email with just the topic ideas, okay?
Okay.
All right, any other questions before we sign off?
I have one.
Yeah, go ahead.
So I finished setting up my single node for Hadoop.
Yes.
What's after that? I don't remember.
So you did the SNMP, you did Hadoop with one single node and you did the count?
No, it's just set up what count thing.
Oh yeah, so remember the example we did in class, the lab of counting the number of words of something?
From the Gutenberg library?
That's right, from the Gutenberg library. But if you remember, we did that just on the terminal itself. I didn't use Hadoop at all.
Yes, sir.
Now, you cannot, so I want you to, basically the minimum is do that, but now do it using the Hadoop program. So if you just told me that you already configured Hadoop on single node, right?
Yes, sir. I'm able to go to it with
And you
I'm
started
able to
with,
have,
right, you start the services. You can see that, the
Yes.
services are on and everything. Okay, good. Now you're gonna have to run a job through Hadoop. And basically you can do the exact same thing that you did, except now you have to use the Hadoop commands. So the Python scripts that we wrote for that lab, they will have to be added into Hadoop. So it's the way that and that should be in that handout. It's basically you type Hadoop, the Hadoop command, and then you're going to specify the mapper is this function, the reducer is this function, and the data is in the Hadoop file, distributed file system. And then at the end of the day, it gives you the exact same result. It gives you a count of the number of books that you counted, but they're just, it's just that the job was not done like in the previous lab. This time it was Hadoop itself. So it distributed out the counting and it, throughout the nodes. So all of that is, if you go to the Hadoop, where I had the Hadoop project, there's several links in there. One of the links is about that.
where you put a folder up there for Hadoop.
Yes, there's a folder for Hadoop that has 4 links. One is like single node, then multi-node, then running a job, and so on.
Where did you put that up recently? Because I looked
No,
for it.
that's always been there. The only thing I said is remember that those are basically describing how Hadoop works. The version of Hadoop that you're using may not be the same version of those links. That's the only thing you have to be aware of. But the basic idea applies. So if you go to, let me go to Blackboard.
Yeah, because I don't see anything that says Hadoop in labs or lecture as a folder. Did you put it in something? Did you put it inside of one of the other lab folders?
I'm going there now. Hold on. It should be there.
Oh, my main man Josh has told me that it's in the MapReduce folder.
Right. Yeah. So
And there it is.
Let me. I'm going there right now. Hold on. So I'm going to labs, and in labs, there's a link called MapReduce. And if you look there, there is, where you submitted the lab, right? The lab we did in class. Remember that lab, you're doing basically that, but now with Hadoop. When we did the lab, we just did everything on the command line, on the terminal. So if you look, there's several links: single node configuration, multi-node configuration, Python scripts in Hadoop, and Hadoop commands. Did you find that, Zach?
Yes, sir.
Right, so you can read through those, and that, that's basically it, except depending on unfortunately, this is Linux, right? Depending on the version of Linux that you're using, things change a little bit here and there. Zach?
Oh, I'm sorry. I didn't know you wanted a response. Yes, I
Okay,
understand.
so this answers your question, I guess it's my question.
Yes, sir. I found it all.
Okay, great, excellent. Yeah, just read through that. Those are very complete. So, they're very detailed.
Thank you.
Any other questions, guys? All right. All right, great. So it seems there's no more questions. So we're gonna stop here for today. And I will see you guys. So I will see you guys on next Monday, okay? Next Monday, we'll start a new topic. Okay?
Okay.
All right, so I'm gonna end the meeting now.
All right.
Bye.
Have a nice day.
You too.